Hi, I figured this evening I'll walk you through how to find missing values in geometric sequences. Now, we've done some work with arithmetic sequences, and it's worked out fairly well. This can be a bit more difficult, so I want to walk you guys through it a bit. Now, here with table 1, you're missing one value. And people are, you might be looking thinking, how can I get from 3 to 12 here? Now notice I made two little loops here because ultimately, since it's geometric, first of all, that means I'm going to be multiplying something. I'm going to be multiplying the same thing twice. Multiplying something by itself. Hopefully that's leading you to something here. Because with geometric sequences, they lead us to exponential functions. And if you remember, exponents are essentially how many times you multiply a value by itself. So, let's see, we're looking here, we're talking about multiplying the same thing twice in a row here. So we got to figure out what value we can multiply twice in a row to get from 3 to 12. Let's see, get from 3 to 12. I'd have to do that using multiplication. So when you're working backwards, and this is a good rule of thumb, think about, alright, what would be my inverse operation here? So the inverse operation for multiplication would be division. So I'm going to divide 3 into 12. I get 4 here. So, let's see. That means that these values here are going to have to give me 4. What when I multiply it twice, or better yet, I'm going to use y here. What when I multiply it twice will give me an answer of 4? Well, this one might be jumping out at you pretty quick. You're thinking, Mr. Gamache, it's 2. It's pretty easy. Alright, so yeah, I multiply 3 times 2, I get 6. 6 times 2, I get 12. Everybody's happy now, right? Okay. So, you might be thinking, this is easy. Now let's take a look at table 2. This is where it gets hairy. We've got 2 missing values. Right here. Now what I like to do is I like to show how many times I'm going to have to multiply here. I'm going to have to do 7 times something. I have to take this value and multiply it by whatever this is. Take this last missing value and multiply it by something to get to 875. So I have multiplication happening 3 times. And again, it's the same value times itself 3 times. Now, I'm doing multiplication. So I'm going to take the 2 values I'm given in my table, 875, and divide it by 7. And if you do that out, trust me on this one, you're going to get 125. You can check it, plug into a calculator, do it out yourself, I guarantee it's 125. Alright, so now it's a little bit more hairy. Because now I've got 3 values I'm supposed to multiply. And when I multiply these 3 values, I'm going to get 125. And not only that, it has to be the same value. So, I have to do, probably want to be using a pen for that. Y times y times y. I'm not going to use y here. I should probably use a different variable. I will do n. N times n times n. That's going to be 125. Now, another way I can write n times n times n is n to the 3rd power. Alright, so what is this value here? Now, you might be thinking, let's divide 125 by 3, but that's not what this is telling us here. It's telling us the same value times itself 3 times is going to get to 125. Now, here's the thing. You want to get n alone here. We want to figure out what this value is we're multiplying by itself 3 times. So, here's what you want to do here. You're cubing a number. That's essentially what you're doing. You're multiplying it by itself 3 times. It's called cubing. In order to find the inverse, you're going to have to find the cube root. So I got to find the cube root of 125, which means what times itself 3 times will get me to 125. Now you can plug this into a calculator. You could ask Siri. Siri will give you the answer if you ask. Or you can, use some guess and check here. Let's see, 1 times 1 times 1, that's definitely not going to give me 125. 2 times 2 times 2, I'll give me 8, that's not 125. 3 times 3 times 3, well, that gives me 27, not 125. 4 times 4 times 4, that gets me 64. I'm getting closer, but not 125. Now, what about 5? If I do 5 times 5, I get 25 times 5, and I get, what do you know, 125. It works. So, I'm going to have to multiply each value here by 5. Multiply the previous value by 5 to get to the next one. Hello, recursive function, or recursive formula, rather. Alright, so 7 times 5 gets me to 35. Nice and easy, I like that. 35 times 5, that's going to give me 175. 175 times 5, guess what that's going to get you? 875. Double check it if you want. Take my word for it. I know what I'm talking about. Alright, so we're getting closer. We're getting some ideas here. So this time we had to find the third root. Up here we had to find, when we're up there, the blue example up here, we had to find the square root. So, are there other roots? Oh yeah, there are other roots. Guess what? Let's take a look down here. We gotta multiply 6 by something to get to the next value. And then multiply this missing value by something to get here. Missing value times something to get here. Missing value times something to get here. 4. I'm thinking I have to multiply something by itself 4 times to get here. Alright, so how am I going to figure out this value? I got to start out with what I have. 96 and 6. Let's divide them up. 96 divided by 6. You will get 16. Take my word for it. You can double check me. Now, let's see. I got to find the fourth root of 16. Do a few things here. You could ask Siri. Siri will tell you what the fourth root of 16 is if you ask. You could Google it. You might have nifty calculators that can do this function for you. Or you can do some guess and check. Start with 1. 1 times 1 times 1 times 1. That does not get me 16. That's not going to work here. 2 times 2 times 2 times 2. Hey, wait a second. 2 times 2, 4. Times 2 is 8. Times 2, 16. Alright. We've got the fourth root of 16. So that means we're going to have to take 6 multiplied by 2. That gets us to 12. 12 times 2 gets us to 24. 24 times 2 gets you to 48. And 48 times 2, you guessed it, gets you to 96. So here's what you should be pulling from this. When you're given 2 values, find how many steps you need to get to the last value here. You're going to have missing ones in the middle. One easy way to do it, you can always just look at how many missing values do I have. I've got 1, 2, 3, 4. It means I'm going to have 5 differences. So you can always just add 1 to how many missing values you have. Some people like the visual of making the loops. I kind of like that myself, but you don't have to. So then you take what you got. Now remember, you're moving forward with multiplication. You move backwards, gotta use inverse, which would be division. We divide out 972 by 4. And I don't know this one off the top of my head. We're going to actually have to do this one out. Witness Mr. Gamache do math. 243. Alright. So, let's see. I'm going to get rid of all my work here. You should never do that, though. Always show your work for your math teacher. Math teachers always want to see your work. So I know that gives me 243. So I want, let's see, how many loops do I have here? 1, 2, 3, 4, 5. I want the fifth root of 243. Any ways you can get here. You could ask Siri. You could use a calculator. You could type into Google, what is the fifth root of 243? You could use some guess and check. I'll tell you, it's not going to be 1. It's not going to be 2. The reason I know that is this number is odd. So it's not going to be a multiple of 2. However, let's try 3. See if it works. 3 times 3, 9. Times 3, 27. Times 3, 81. I like the sound of this. 81 times 3, 243. The fifth root of 243 equals 3. That means I'm going to be multiplying each previous value by 3. 4 times 3, 12. 12 times 3, 36. 36 times 3, 108. 108 times 3, 324. 324 times 3, 972. All right, so this is how you're going to be finding your missing values in geometric sequences. Best of luck.